In 1945, American bombs leveled the Honda Motor Company's factory in Hamamatsu, Japan. Soichiro Honda had been making piston rings for Toyota's war effort. The factory was ash. He was 38 years old. He had no capital, no facility, no supply chain. He had a country that was importing food because its agricultural infrastructure had been destroyed, along with everything else. What he did next explains why, 75 years later, Honda sells 16 million motorcycles per year, more than any other manufacturer on Earth, and why a 1998 Honda CB750 with 200,000 miles on it is considered an unremarkable ownership experience, while a European motorcycle of the same era with half those miles is considered exceptional. The answer does not begin with engineering. It begins with a decision made by an American statistician that the American industry refused to hear, and with the specific conditions of post-war Japan that made the Japanese industry desperate enough to listen. I'm Jimmy. This is the full documented story. Act 1. The American nobody in America would listen to. D.U. Edwards Deming was a statistician and industrial consultant who spent 2 decades trying to convince American factory managers of a single argument. When products come out defective, Deming said, the fault almost never rests with the workers on the line. The real problem is the system that management designed around them. Fix the system, and quality follows naturally. American executives in Detroit and Pittsburgh were not interested. After World War II, the United States was the only major industrial economy left standing. Factories could barely keep up with global demand. Nobody saw a reason to change what appeared to be working. Japan had every reason to listen. The country was rebuilding from total destruction, with limited raw steel, minimal precision tooling, and virtually no investment capital. Japanese industry understood that economic survival depended on one strategy: become an exporter of manufactured goods that the rest of the world would actually choose to buy. In the summer of 1950, the Union of Japanese Scientists and Engineers invited Deming to lecture in Tokyo. He found an audience that was desperate for exactly the kind of help he had been offering to deaf ears at home. He taught 450 Japanese engineers and senior managers statistical quality control, the principle that you use data to identify and eliminate the root causes of defects during the manufacturing process rather than catching them at the end. He taught them that quality was not something you inspected into a product after it was built. It was a management responsibility woven into every stage of production. What happened next surprised even Deming. Japanese companies went far beyond adopting his ideas. They internalized them, expanded on them, and built entire corporate philosophies around principles he had only sketched in outline. In 1960, Japan's Prime Minister awarded Deming the Order of the Sacred Treasure for his contributions to Japan's industrial rebirth. America would not pay real attention to this man for another 20 years. Act 2. How this reached the motorcycle industry specifically. Honda, Yamaha, Kawasaki, and Suzuki all emerged as significant manufacturers in the 1950s and the 1960s, the exact decades when Deming's quality principles were being absorbed and expanded throughout Japanese industry. They were not building motorcycles in a cultural vacuum. They were building motorcycles inside the same industrial culture that was simultaneously producing the Toyota production system, the kaizen philosophy, and the specific manufacturing discipline that would eventually demonstrate its full capability at the Numi factory in Fremont, California. It was the shuttered General Motors plant where Toyota took the same workforce that had produced the worst quality vehicles in the GM system and, without replacing a single worker, reduced defects from 135 per 100 vehicles to 45. Same building, same union, many of the same people, different management philosophy, completely different outcome. The motorcycle manufacturers absorbed the same philosophy through the same cultural transmission. 3 principles specifically. The first was jidoka, automation with a human touch. At every workstation, any worker had the authority to stop the production line the moment they spotted a defect. The line would not restart until the problem was identified at its root cause and corrected. In American motorcycle manufacturing of the same era, the assembly line was sacred. If a component failed to seat correctly, the machine moved forward anyway. Defects were supposed to be caught by inspectors at the end. Sometimes they were. Sometimes they shipped. The second was kaizen, continuous improvement, as a permanent organizational habit rather than a program with a launch date and a completion target. Assembly line workers submitted improvement suggestions. Management acted on them. A minor adjustment in how a component was installed could compound over years into measurable gains in quality and longevity. Honda's Georgetown, Kentucky plant, where American workers build Honda motorcycles under the same philosophy, implemented thousands of employee suggestions per year. The third was just-in-time manufacturing. Born from Japan's post-war scarcity of capital for parts warehouses, just-in-time required components to arrive exactly when needed in exact quantities. If a single supplier shipped a defective batch, the problem surfaced immediately. Problems that surface immediately get corrected faster than problems that hide inside a warehouse of inventory. These are not abstract principles. They are the documented explanation for a 1982 Honda CB900F that a writer in Minnesota is still commuting on in 2026. Act 3. The specific engineering decisions that followed the philosophy. The Yamaha engineer interviewed after Yamaha clinched the MotoGP manufacturer's trophy was asked why Japan produces clearly better motorcycles than the competition. His answer, documented in a comment with 43 likes on the most watched Japanese motorcycle video on YouTube, was specific and underreported. In Japan, he said, there is no significant military-industrial complex. The top-tier engineers go into racing and manufacturing rather than defense. That observation has a direct consequence. The best engineering talent in Japan spent 50 years building motorcycles. Not weapon systems, not defense contracts. Motorcycles. The concentration of engineering talent on the specific problem of producing a reliable, durable, rideable machine at an accessible price produced outcomes that reflect 50 years of elite engineering attention on a single problem category. The specific decisions that resulted are documented across Honda, Yamaha, Kawasaki, and Suzuki's production history. Conservative engineering timelines. The Honda CB engine series and the Yamaha parallel twin platform have been refined across decades rather than reinvented every model year. The architecture stays stable. Each successive generation addresses known durability issues, improves material quality, and builds on a tested foundation. The downstream consequence is that replacement parts are widely available. Independent mechanics understand the platform across multiple model years, and repair costs decline as familiarity increases. Generous engineering tolerances. The Honda CG125 engine, the most widely produced motorcycle engine in history, still running in East African Boda fleets after 40 years of daily service, was designed with bearing clearances and oil passage dimensions that accommodate minor variations in maintenance quality and minor contamination without cascading into catastrophic failure. Compare this to a modern European sport engine running main bearing clearances of 0.5 of an inch, where a 30-micron metal particle that a CG25 engine circulates harmlessly can destroy a precision engine before the next oil change interval. Racing-derived production engineering. Honda's race program knowledge, the RC166 six-cylinder race engine that revved past 18,000 revolutions per minute and powered Honda to Grand Prix dominance in 1966, directly informed the CB750's production engine design. Yamaha's competition in every form of motorcycle racing, from MotoGP to endurance to motocross, has produced a half-century of material science, metallurgy, and bearing knowledge that transfers into production machines. The rider who buys a Yamaha R1 is buying a machine whose engineering lineage runs directly to championship-winning race programs. This is not marketing language. It is the documented transfer of racing engineering knowledge into production motorcycle design over 5 decades. The Japanese engineering philosophy described here, conservative timelines, generous tolerances, racing-derived material science, produces machines with specific characteristics that matter when you are buying used. The tires on a used Japanese machine, the service history indicators, the specific mileage benchmarks that separate a machine that has been maintained within the design envelope from one that is not. Section 7 of the 2026 Motorcycle Buyer's Bible has the complete used Japanese motorcycle inspection checklist. Section 5 has the specific model year recommendations across Honda, Yamaha, Kawasaki, and Suzuki for the 2026 market where used Japanese machines are currently available at prices that have not existed in 15 years. Link in the description. It was $97, now $9. Act 4. The scale advantage nobody discusses. Honda sells 16 million motorcycles per year. The comment with 1,100 likes on the Yami Noob Japanese motorcycle video notes accurately that 15 million of those are scooters sold in India. The observation is intended as a deflation of Honda's numbers. It actually proves the opposite point. The engineering, material science, and manufacturing knowledge required to produce a 110 cubic centimeter commuter scooter that a family in rural India depends on for its primary transportation, that must start reliably in monsoon humidity, in high summer heat, and on fuel quality that varies significantly from the laboratory specification, is not lower-tier engineering. It is the same engineering philosophy applied to the most demanding real-world conditions available. A machine that passes the Indian commuter test at scale is a machine whose engine design has been validated by millions of real-world hours under conditions that no European or American test program has systematically addressed. The learning that comes from producing 16 million units per year flows back into the engineering of everything Honda makes, including the motorcycles sold at American dealers. The scale numbers for comparison: Harley-Davidson produces approximately 180,000 motorcycles per year. Ducati produces approximately 60,000. BMW Motorrad produces approximately 200,000. Honda produces 16 million. Yamaha produces approximately 5.5 million. The engineering feedback loop that 16 million annual units creates is simply not available to a manufacturer producing 60,000. That feedback loop is not just about volume, it is about the diversity of conditions those machines operate in. Honda's motorcycles run in Japanese cities, Indian villages, African rural routes, Brazilian highways, American suburb, and European mountain passes simultaneously. Every failure mode that emerges in any of those environments is documented, analyzed, and addressed in the next production cycle. The manufacturer producing 60,000 units in a single cultural and geographic context is working with a fundamentally smaller data set. Act 5. The race program connection. Between 1959 and 1967, Honda won 137 World Championship races and 16 World Constructor Championships in Grand Prix motorcycle racing. They did this while simultaneously transforming American motorcycle culture with the You Meet the Nicest People campaign, and while building the production infrastructure that would eventually allow them to produce millions of units annually. The connection between the race program and the production machines is not incidental. It is structural. Honda's race engineers in the 1960s were solving problems that the production motorcycle had never faced at the same intensity: how to extract maximum power from a specific displacement while maintaining mechanical integrity across a race distance, how to manage heat in an engine running at sustained maximum output, how to design bearing and valve train systems that survive conditions that would destroy conventional components. The solutions to those problems, the metallurgy, the oil system design, the valve train geometry, transferred directly into production engines. The RC166, Honda's 250cc six-cylinder race engine that revved past 18,000 revolutions per minute, produced engineering knowledge that informed the CB750's production engine in 1969. The specific decision to use plain bearings rather than rolling bearings in the CB750, a choice that reduced peak revolutions per minute capability but dramatically increased reliability and longevity, came from engineers who understood the full range of bearing behavior because they had built machines that used both types at the absolute limits of each. Yamaha's MotoGP program has run continuously since the series began. The company's research and development investment in racing is not primarily about selling motorcycles to racing fans. It is about maintaining a development environment where the engineers who design production motorcycles are simultaneously solving problems at the engineering frontier. The knowledge created at the frontier flows into the product that the commuter buys at a dealer. Kawasaki's H2R, a supercharged track-only machine producing 310 horsepower, exists not primarily as a commercial product, but as a demonstration of what the engineering team is capable of. The materials and aerodynamic knowledge developed for the H2R program appears in production machines: the carbon fiber expertise, the supercharger heat management, the high-strength steel alloys. This is the same mechanism the Toyota script documents in automotive manufacturing. The racing program creates engineers who have solved problems at the frontier. Those engineers design the production machines. The production machines inherit the frontier knowledge. Act 6. What the data says and why the gap persists. The reliability data is not ambiguous. In the most recent industry-wide consumer reliability surveys, the Japanese brands occupy the top positions consistently. Honda and Yamaha lead in long-term reliability, with Kawasaki and Suzuki close behind. The gap between Japanese and non-Japanese brands and reported problems per 100 machines and an annual unscheduled maintenance cost has been consistent for decades. Annual maintenance cost data from independent ownership studies shows Honda and Yamaha owners spending approximately $300 to $400 per year in unscheduled maintenance versus $600 to $900 for premium European brands. Over a 10-year ownership period, that difference is $2,000 to $5,000 in additional costs on the non-Japanese machine. The Italian motorcycle community on YouTube is refreshingly honest about this. A comment with 150 likes from an Italian writer says, "I'm from Italy where so many cool bikes are manufactured. None can beat Japanese quality. They really can forge metal. If we Italians were capable of building such engines, we would sell them for $100,000 each." The ZX-10R rider, watching his MV Agusta friend's engine oil leak from the seat of his Kawasaki, captures the daily lived reality of the gap. The mechanic who worked at both a Ducati and a BMW shop reported a crankshaft that split in two on a 2-year-old Ducati and a valve check that took 7 to 9 hours on a newer model. That is the maintenance reality of engineering that prioritizes character and performance over longevity. None of this means Italian or German or American motorcycles are bad machines. It means they make different trade-offs. Character, aesthetics, specific performance characteristics, brand identity, these are real values that real riders pay real premiums for. The premium is honest if the buyer understands what it is, the cost of a machine that was not optimized for the same durability targets as a Honda. What the gap demonstrates is that Japanese manufacturers made a different set of decisions, rooted in post-war necessity, shaped by Deming's quality philosophy, reinforced by decades of racing-derived engineering, and multiplied by production scale that no other motorcycle manufacturer approaches. Those decisions produced an outcome that the data consistently confirms. The OEM tire on a new Japanese motorcycle is where the philosophy and the commercial reality diverge most directly. Section 2 of the 2026 Motorcycle Buyer's Bible documents the OEM tire scam. The tires fitted to your new Honda or Yamaha at the factory use a fleet compound that wears 30 to 50% faster than the retail version of the same tire with the same name. The machine that was engineered to last 100,000 miles ships on tires designed to be replaced in 6,000. That is a documented commercial decision that has nothing to do with the engineering philosophy and everything to do with manufacturer relationships with tire companies. Section 2 has the specific tire recommendations for the 2026 market across every Japanese platform category. Link in the description. It was $97. Now $9. Act 7. Why the gap is not closed and probably won't. The most important question in this story is the same one that baffled manufacturing scholars studying Toyota for 40 years. If the philosophy is documented, if the principles are taught in every business school on Earth, if competitors have spent billions attempting to replicate it, why do Japanese manufacturers still consistently finish at the top of reliability studies? This is a question about reliability. The answer is the same as the automotive answer. The end-on cord is a piece of rope. Kaizen is a word you can look up in a dictionary. Any manufacturer anywhere can install these tools in weeks. What cannot be installed on any timeline is the organizational culture that gives those tools meaning. General Motors had access to Toyota's entire production system during the new Meiji years. They rotated managers through the plant continuously. They sent delegations to Japan. They documented every process. They could not replicate the outcome because the culture that made the processes function, the shared conviction at every level of the organization that quality is not a department you fund, but a way of approaching every decision, was not transferable through policy memos and corporate training programs. The same dynamic operates in the motorcycle industry. A European manufacturer can study Honda's production methods in detail. They can implement the techniques. They will not produce the same outcome because the organizational culture that generates the techniques, the engineering pipeline that runs from racing programs through production design, the manufacturing feedback loop that 16 million annual units creates, these are not techniques. They are the accumulated output of 70 years of an entire industrial culture directed at a single problem. Soichiro Honda rebuilt his company from rubble and ash in 1945 with no capital and no factory. He started with surplus engines from military radio generators, fitted to bicycle frames, and sold them as motorized bikes to people who could not afford conventional transportation in a country that had almost nothing. The machine that emerged from that origin, driven by necessity, shaped by the quality philosophy of an American statistician nobody in America would listen to, refined across 70 years of racing programs and production scale that no competitor has approached, is what you are buying when you buy a Japanese motorcycle. A 200,000-mile CB750 in Minnesota is not exceptional. It is the expected outcome of a manufacturing philosophy applied consistently for 70 years.